Hi friends, in the second experiment I would like to explain the program for collection of samples from the PPG sensor and to process the samples through the code explained in the previous videos to find the heart rate of the person. Okay, these are all the variable declarations. X is an integer array of for collecting 150 samples from the PPG sensor, and this is an integer counter, and this counter helps to take the 150 samples from the PPG sensor. Initially we are setting up the baud rate and delay, and inside the loop we are writing the if condition. We are setting inside the loop we are writing the if condition if counter is less than 150, that is if 0 is less than 150, because initially counter will be 0, it will goes into the loop, it will go into the loop, delay 20, that is 20 milliseconds. After it will analog read A0. The sample from the pin A0 of the Arduino board is collected into the integer array of 150, that is x of 0. Analog read is the command which is used to collect the analog sample from the pin A0 of the Arduino. Then we are printing this value, and then we are incrementing the counter by 1, that is next time the counter will become 1, and once again this loop is checked, that is 1 is less than 150, yes, true. Once again the process is repeated and the counter is increased to 2, then 2 is less than 150. In this way the program helps to collect the 150 samples from the PPG sensor. Okay, here is the code which was explained in the previous videos. Now I will explain this code briefly. This is the sample of this is the array of the samples which are collected now. Then these are all the variable declarations. This is the array to find the output, and this is the array of element string which is used to detect the average number of samples between the two peaks, and this p is equals to 5, q is equals to 10 are the moving average filter parameters. Now in the void setup we are setting up the baud rate, and this is the code for the first moving average filter. Moving average filter, it is just a low pass filter, and it takes the average of the previous p samples, where p is the parameter of that moving average filter. So this is the code for the moving average filter. We use two moving average filters in this program. First we give our samples to the first moving average filter, then the output of the first moving average filter is given to the first order derivative filter, which is shown here. This is the code for the first order derivative filter, and in the third step we are giving the output of the first order derivative filter to the another moving average filter of the parameter q. So p and q are declared initially. Okay, I will show the output after the third step, that is second moving average filter. I am running this. Okay, I am opening the serial plotter. Yeah, we are going to see this type of plot. Okay. Okay, after seeing the plot, we are getting the 4 peaks, 1, 2, 3 and 4, but when you observe, this is not our systolic peak. We have to get rid of this peak. So how can we get rid of this peak? By finding the threshold and applying the threshold to some extent of this level, then we can get rid of this peak. So in this program I am going to find the threshold so that it will come to here, so that we can neglect this small peak, and we can continue with these peaks which are realistic and systolic peaks. This is the code for finding the threshold. We are taking the average of those peaks, so that after that we are neglecting the peak which is less than the threshold, that is that peak will be discarded. Then we are collecting the we are collecting the sample number of this peak, this peak, this peak and this peak. Already this peak will be discarded by writing the y of I is greater than the threshold. For every that condition we are taking the peak, this. So we are collecting the sample number of this peak and the sample number of this peak into an array of h, which is declared above, array of 10. So we are collecting the sample number. Let us say this sample number is 5 and this sample number is 50, and then we are calculating the difference between the sample numbers. That is, we are counting the number of samples between the two peaks. If it is this is 5 and this is 50, then the number of samples between the two peaks will be 45, and after this number is 50, this number is 100, then the number of samples between will be 50. After that we are calculating the average number of samples between the two peaks, that is 45 plus 50 by 2. Then we will get the average number of samples between the two peaks. In this way we calculate the average number of samples between the two peaks. I will show it in the code. This is the program to find the average number of samples between the two peaks, and then when we get the average number of samples between the two peaks, then we calculate the heartbeat as follows. Like for one beat, if I will find the, okay, I will show in this program the average number of samples between the two peaks. I will comment on this thing, and in this code I am taking D as the average number of samples between the two peaks. Moving serial monitor. Yes, you can see serial print T. This is the 39.50, that is there are 39.50 average samples between the two peaks. So we calculate the BPM as follows. For one beat there are 39.50 samples, and we know the sampling frequency for our code is 50 Hz. By taking the delay 20, which are collected above, we have written delay 20 milliseconds in the top to collect the samples. That 20 milliseconds is nothing but our sampling time. So for 20 milliseconds, that is 0.02 milliseconds, and if we take the reciprocal of it, it will become 50 Hz. That is our sampling frequency. So we can get for one beat there are 39.50 average samples, and so for each sample it will take 1/50 seconds. So for one beat we are getting 39.50 into 1/50 seconds, that is 39.50 by 50 seconds. So for 1 second we will get how many beats? 50 by 39.50 beats. So for 60 seconds we will get 60 into 50 by 39.50 beats. That is our BPM. So I will show the BPM now for this sample of I'm opening the serial monitor. Yes, heartbeat is in BPM is 75. So this is our heartbeat. So in this way we can calculate the heartbeat using this program. Thank you for watching this video.